Friends, in this session, we will see where do the trees find applications. Representative list is set representation, decision trees, game trees, heap sort. So, first let's start with heap sort. For that, we will sort the following planets of the solar system according to their position from Sun. First of all, let's build a heap. Heap is a special kind of binary tree which does not contain any unused space as in case of array representation. So let's start constructing the heap from the given planets. So here, planet Jupiter will be the root node. Next, planet Pluto is inserted. As in a binary tree, the parent node is greater than the child node. So, Pluto becomes the root node and Jupiter becomes the child node. Next, Mercury is added to right side of Pluto. Then, Neptune is inserted to the left of Jupiter. But Neptune is larger in terms of distance from the Sun. So, it becomes the parent node of Jupiter. Next is planet Earth, which is inserted to the right of Neptune. Then Mars is added to the left of Mercury. As Mars is farther away from Sun, it becomes the parent node of Mercury. Next is Uranus, which is inserted to the right of Mars. But as its distance from the Sun is greater than Mars, it becomes the parent node of Mercury and Mars. Then Saturn is added to the left of Jupiter, but it is farther than Jupiter. So Saturn becomes the parent node of Jupiter. At last, Venus is inserted to the right side of Saturn. After the construction of heap, we will represent this heap of planets as an array. Sorting operation is very fast in the array which is created from a heap. Now let's sort the planets according to their distance from the Sun using heap sort. In heap sort, the greatest element, that is, the farthest planet from Sun, is placed at the end of the array. So here, Pluto is placed at the last position. Heap sort algorithm implies that Venus must be moved to the position of the planet whose distance from the Sun is greater than that of Venus. In this case, it is Jupiter. Then Jupiter is shifted in the place of Saturn. Likewise, Saturn is placed in position of Uranus. And Uranus is placed at the position of Neptune. Thus, now Neptune becomes the 0th element. Next farthest planet is Neptune, which is placed before Pluto. So Venus is shifted in place of Mars. Then Mars in place of Jupiter. Jupiter in place of Saturn. Uranus is replaced by Saturn and Uranus is placed at 0th position. In the same way, all the other planets are placed at their proper position. As a result, sorted set of planets is obtained. This would not have been possible without tree representation of the data. Fine. Now let's see how to represent the sets using trees. For example, Consider the three disjoint sets S1, S2 and S3. The tree representation of the sets is as follows. Now, if we want to take the union of set S1 and S2, we simply make one of the trees a subtree of the other. S1 union S2 could then have one of the following representations. Another interesting application of trees is in the playing of games such as tic-tac-toe, chess, nim, checkers, etc. As an example, let us consider the game of tic-tac-toe. This game is played by two players, A and B. The game is represented by the position of board. The players A and B make moves alternately. A legal move consists of marking X or O on the board, and the player who marks X or O vertically, horizontally or diagonally on the board wins the game. So, we can represent the moves of the player with the help of a tree known as game tree. The root node represents the starting position. Each node of the tree represents the state of the board. Observe that the children of any particular node correspond to the set of allowable moves from the board position of the parent node. The leaf nodes of the tree correspond to board positions where there is no move. So this is how trees are important in various applications.